Okay, so we're back now. I want to go ahead and present a few slides. Before I do that, though, just wrapping up on our guest speaker. So we've come up with a way to sort of thank our speakers and sort of share some of your feedback. I'm going to put Pedram on the spot. So Pedram, you want to tell everybody sort of what we're doing with some of their comments and things, and what we're sending to the guest speaker?
So the lecture quizzes that you guys take, I just randomly select some of you guys' responses and then compile them in a list, and I send it out to the guest speaker, and they just get to see some of your responses.
Yeah, we sort of came across this as a good way to sort of provide feedback. I know Bo Keat was one of our early speakers. He was asking, well, what do the students have to say about the conversation or what we did? And we said, well, an easy way to do that, you guys are already putting stuff online, so we randomly select about 8 of those and send it off to the guest speaker so we can kind of see what you guys, they know what they said, but they can see what you guys thought their key points were. It's kind of pretty valuable for them to start, hearing how they're articulating their lead message to students. So just let you know that your comments online are going to even more good use, all right? Okay, so with that, I want to hit the highlight reel for last week. So this was Analyze 1, your first section of analysis. So the real focus in the Analyze section, if you think about it, we've identified a problem, we figured out how to measure the problem, and now what we want to do in the Analyze phase is we really want to do some figuring out what the root cause of the problem is. So it's trying to get to that root cause. So one of the things we're doing is we have to answer the question, what should I analyze? And there's some, I don't want to say soft tools, but non-statistical tools that we use to answer that question. These might be cause and effect diagrams or fishbone diagrams, box plots, scatter plots, right? All those are things that we would potentially use, non-statistical tools. We also have some statistical tools that we use to try to get to the root cause of a particular problem. Now, one of my favorite sayings in Lean is we see together, we know together, and we act together. So we see together, we know together, we act together. And it's a little bit of, one of the themes coming through our guest speakers is the people doing the work and getting people together to solve problems. And if they're actually working together and they come up with a solution, it's a lot more likely to happen or a lot more likely to be implemented, right? So we go and we see it together, we're seeing the data, we're understanding the data. We say, that's what the problem is, that's what the issue is. And then based on that, then we go ahead and we act together. Now, another thing that comes in, and this is where, if you think of these as, these are sort of go-to Lean tools. Well, when you do Six Sigma, and you're going to Lean Six Sigma, we add on a layer of sort of statistical analysis and statistical rigor. So we've got these other tools down here. If you think about these tools, these are really good tools for visual management, or having teams work together to create these things and see what's going on. When you're down here, this is a little bit more of a lonely job. You don't see, multiple people, pushing the buttons on an engine room or statistical analysis figure those out. So one way you could sort of think about this is sort of modifies the statement here is, I analyze, right? So I'm going ahead and do this analysis. But then we see together, we know together, we act together. So it sort of feeds into that. So you're not necessarily doing this, for yourself and your own insight, but you got to think about this. Okay, how's this analysis going to convince my team to get the buy-in? How's it going to get the buy-in of management so we can go forward with this improvement? Any questions about that? How that works? What that's about? So analysis is about trying to figure out what the root cause is. All right, so I want to take you back to, what is it, St. Sigma? So we introduced this problem. It was a hospital. They're trying to prove this concept of using the domain process to solve problems and improvement. And they were looking at a blood analysis analysis process or a glucose testing process. And they had a bunch of data to look at that. And we're interested now in trying to figure out maybe what some of the relationships are in the process. So I'm not going to actually go through and do the analysis, and I've sort of brought it to another element here, where as opposed to using the engine room, which you're certainly welcome to use, also pointing out that we've got these Morstein templates that you can use, and they're downloadable. You might have come across one or two of them as you go through the learning, but I've also got the whole list of these Excel templates is posted on Polylearn. And what I suggest is before you leave this class, download that whole list so you got them on your memory stick or on your computer. So when you get into your job and you want a quick, easy way to do some of these analysis, you just knock it out on Excel. Because in your work, you might not have Minitab, you might not have Engine Room or some other statistical packages, but everybody's got Excel, right? So you want to make sure you have that. So anyway, went through, and I needed to manipulate the data a little bit. So I looked at putting together, in addition to the stuff, the raw data we had, observations, hour of the day, the number of cycle time, amount of cycle time minutes, and whatever standard routine. I looked at summarizing and look at the average time per hour of the day. So this is a 24-hour clock. This is the average time. So every time I add, an hour of the day. So here's these two guys are threes. Hour 3 of the day, 3 o'clock in the morning, I guess. And here's the time. And those along with other threes that you don't need necessarily see there averaged into like 43 minutes, right, as far as the total time. And then I also went through and I said, okay, what's the demand by hour of the day? So for that hour of the day, what was the demand? How often did they have to do that blood work? So now I've got 3 additional kinds of variables that I can do and do an analysis for. And I'm interested in, well, what's the relationship here, right? What's the relationship between these variables? Now I'm going to use a scatter plot to look at this, and this is the scatter plot template from Excel template from Morstein, right? So here's the way this might be approached, right? So if you're going to do this for your mini project, and this was your problem, I said, why did I select the tool? Scatter plot was selected in this case to better understand the relationship between the time it takes to do a blood test, cycle time, and the load on the process, so the demand. So we're looking at what's the relationship between demand and cycle time. So I got those 2 columns. I pasted them into my little Excel spreadsheet. It spits out a scatter plot. So there's a scatter plot. It also will draw in a regression line for that scatter plot, and it'll calculate a correlation coefficient R and then a constant of correlation or an R squared. And so I look at that information and say, okay, my interpretation, scatter plot shows that there's a positive relationship, right? Just state the obvious, positive relationship between demand and the cycle time for the process. The R squared value is 0.48. I know that the R squared represents the proportion of the variance that's explained by the relationship there. So 48% of the cycle time is explained by the demand load, right? So we can try, so almost half the variation in cycle time, so it explains that. One thing we can do is we try to even out the load on the system so we don't get these, particularly high values. So try to eliminate some of these higher level demand things to be able to sort of even that out. We can also check for other sources of variation because only 50% of the problems explained by demand. We might go back and say, well, good question. Next question is, well, what's the other 50%? Right? And maybe I can go back and see what that looks like. So that would be an example of a scatter plot or a tool that you can use. Once again, once you've done the data manipulation to get the right data in place, executing that little analysis really doesn't take very much time. You get some good data to share with your team, right? Hidden gems in this section, I like the 5 whys analysis spreadsheet team. So one of the other tools we would use to try to figure out the root cause is the 5 whys. Just kind of keep on asking why until we get down to something we can actually fix permanently and put in place. Well, Morsi shows us this 5 why analysis sheet where we've got these 5 questions, but then what's our temporary fix once we get down to the root cause or the thing that we're going to fix? What's our final countermeasure, maybe the long-term fix? And then how do we verify that this improvement was really done in our place? And we've got some pictures maybe of what the problem is or what the data looks like. So it's a nice little tool to sort of put together a story for you to get buy-in from your manager or for your team. Right? Always remember, correlation does not equal causation. And the other sort of big thing is go visual, plot the data. I always like to say when I'm working with teams at Kaizen events, go big, go vertical. So go big means get it up there on a flip chart or page, and go vertical means don't be just sort of writing notes down on a little piece of paper. Get it up there on a whiteboard or on some sort of sheet so then we can all sort of see it and all sort of keep track of what the ideas are and as they go through. So go big, go vertical is also a kind of a neat concept to apply in working with improvement teams. Okay. I have one more thing. And I'm going to hit you guys up since you are sitting here in a room. Who has not yet shared their Greenbelt story? Who has not taken a shot at this yet? Got a couple of good volunteers. My memory's not really long, so if you actually present it again, I probably wouldn't catch it. But maybe by the end it would start to sound familiar a little bit. Okay, so here's the goal, right? Lean always picks goals, picks targets. I want to get 2. I want to get 2 today. 2 of you, stand up and do this for us. Let's take a shot at it. Seen it before, it's not hard, we'll help you out. Get stuck. It'd be a good way to sort of figure out, work through a little thinking through your mini projects. 2 people, let's go. All right, let's give them a hand. We're just gonna stand up and do it. We're gonna turn the camera on. How does that sound?
Yeah, it works.
All right. So, where do you want, Doc?
Yes.
Yeah, I could go there anyway.
No, you can stand there with us.
All right.
You good? All right. Okay, so you just have to walk through this. So, take her away.
All right. My name is Ryan Osterling. I'm working with Dr. Olson and the IT department to help get posters done for the mini project. So everybody finishes their mini project, and if we can get people to just submit a format of the poster, you can get extra credit points. It should be pretty easy. I'm basically probably going to try to reformat a little bit, just make it easy for everybody to do, and then you could submit it, get free extra credit points, get your poster shown at the Central Coast Lean gathering.
So it's Ryan, right?
You got it.
Okay. And I always want to say Mike, but it's going to be Ryan. That's your dad, right? Okay. So we're going to go with Ryan. So give me just a statement of the problem. It's a simple statement of the problem.
So the problem is historically there's been a lack of people who turn in the poster format.
Excellent. Okay. What's the key measure you're going to use?
Make it easier for people to turn in and make it so that people feel a reason to turn in the poster.
So that's more what
give them a value.
That's more what you're going to do. How are you going to measure that? How are you going to measure easiness?
Just how many people turn in the poster.
Okay, so you're going to measure how many people turns in the poster, right? What analysis are you going to do, or are you going to do? What do you think? This is like brand new stuff, so.
Like 10 tools. Well, yeah, obviously not all 10, but like
in the
analysis.
in the analyze phase.
I mean, I'd definitely be asking a lot of why questions. So the 5 whys.
Okay, so 5 whys is going to be one of your key tools you're going to use in the analysis phase.
Yeah. That's it.
That's it.
Perfect.
All right. Yeah. All right. Somebody else want to walk through that? Need one more. One more video star here. Let's go. Recorded for posterity. Yeah, YouTube for years. Maybe forever, right? Isn't that what YouTube's doing? Let's take a shot. All right, so we'll up the pressure here. Who's already done one of these? Okay, so I see a lot of people that don't have their hands up yet. Okay, so it could be any one of you that didn't put up your hands. All right. You gonna go for it? All right, let's give me a hand here. All right.
My name is Mason Kuczynski. I guess the organization the Poly IT303 class. The process is the setup process. The problem is that we're not starting on time. Key measures. So are these like the tools from the 10 tools?
Well, they could be, but the key measure is like, what measure are you going to do?
Making sure that the class starts on time.
Well, making sure is something you would do. How are you going to measure the fact as to whether the class starts on time?
Well, I was going to use a histogram and analysis of
So
starting times for classes.
Okay, starting time for classes. So you're going to measure the starting time for class.
Yeah, okay, so the time that the setup process starts and then the actual time that the class starts.
Okay, so the difference between this when the setup starts and the class starts, so that difference in time, that's your measure, right? It's that time difference, right? What analysis do you think you're going to do? I realize this is early.
So like a cause and effect type situation.
Okay, so all the different things that would stop us from potentially starting on time, you're going to go ahead and try to figure out what those are with the cause and effect diagram. Yeah. Excellent. Okay, good start. All right, well, my thanks to the 2 people that sort of stood up and helped out the class there. Be thinking about that as you're sort of going through. You guys that did it early, thank you very much. But you know, we're adding on as we go through. What we're going to try to do, the last 2 class sessions, there's going to be a focus on trying to do a 60-second presentation of your mini project. All right? So if you were in an elevator with a top executive and he said, well, what did you ever do in that class? Well, Lou, 60 seconds, you can kind of walk right through it and talk about some great results you had. All right, I say we call it quits for today. I'll hang around for a little bit if you want to chat, but otherwise we'll see you on Monday if you're going to come to the movie. All right, that's it.